Welcome to Organic Chemistry. In this class, we're going to be taking a lot of what we've learned in general and AP chemistry, and we're going to be expanding on that by examining specifically organic compounds. Organic compounds are compounds that center around the carbon atom, which most organic life and most things we eat and a lot of extremely useful things like medicine and food are based around carbon atoms. All of these things fall into organic chemistry. We can look at anything from medicines to synthetic dyes to synthetic flavorings. In this class, we're going to be focused on a few key areas of organic chemistry. This field of knowledge can branch much wider than we're going into, but our focus is going to be really on the foundations of organic chemistry so that when you might take it later in college, it'll be a lot easier to grasp a lot of these concepts because a lot of these concepts are very foundational. The first one, in the first unit, we're going to be looking at nomenclature. Within nomenclature, which is a systematic naming system, we're going to be looking at how do we name different organic molecules. It is very systematic. And we're going to be seeing that there are certain functional groups that have a very exact pattern that will give our molecules both specific structure and specific function, and we'll name them in a specific way. So we'll see something like an alcohol will have a very specific group of oxygen and hydrogen on that molecule, and we'll always give these very similar properties. We're going to see that a lot. Our second unit is going to focus on isomerism. This is going to look at the nature of organic molecules to become quite large and their ability to form different structures with the same number of elements. So I could have something like 6 carbons and 12 hydrogens. I could have C6H12. I could have that forming a straight line, or I could have that forming a ring structure. There are a lot of different ways that these molecules can go together. And so we're going to see how we differentiate that and what effect that difference has on the structure of a molecule, and really its stability. The next point we're going to make is chirality. Chirality is a very subtle point. Within organic chemistry, it can seem very nuanced, very technical, and almost silly. Why should we worry about that? But within biological systems, chirality is everything. It's going to look at not just how are these atoms structured together, but what orientation are they structured together in? I could have molecules that have a shape going this way, and I could have molecules that have a shape going this way. And those would give them significant property differences. So once again, we're going to be really focused on the structure and function and stability throughout these first 3 units. After that, we're going to start looking at organic reactions, which will differ a little bit from the reaction that we looked at in general chemistry. We're going to be less focused on balancing reactions and doing things like stoichiometric conversions, and more focused on identifying the process that a molecule goes through within a chemical reaction. We call these mechanisms. And so in units 4 and 5, we're going to be looking at the mechanisms that drive certain reaction types. Along with those reactions, we're going to be able to look at the stability of certain molecules. So the big ideas that we'll be looking at in this course will be the stability of molecules, of different chemicals, of different organic structures. We'll be looking at the structure and function. We'll see that having a carboxylic acid on the end of a carbon chain gives it wildly different properties than having an alcohol on the end of it, or having something like a halogen on the end of it. We will see mechanisms. Mechanisms is going to be our third big idea. We're going to see that it's very important to identify how these reactions are able to proceed and how they're able to move through certain steps in order to create products, allowing us to make predictions and create specific compounds that we might need for a later use. Maybe it's a medicine, maybe it's a dye, maybe it's a food product, maybe it's just a precursor for another reaction, maybe it's an ingredient. So we'll be looking at those big ideas. Now, in this class, we're also going to be doing some labs. And these labs are going to focus on identifying specific techniques within organic chemistry, because there can be a lot more complexity within organic chemistry labs. So within organic chemistry, we're going to be using a number of different lab techniques to do a number of different processes. Sometimes we have a specific reaction that needs to be worked on under a certain temperature that's near its evaporation point, that's near its boiling point. So we would need to do something called a reflux to keep it from all escaping out of our vessel. That's just one example. But a lot of organic labs are going to require not just the creation of a product, but the separation of that product from multiple byproducts. Think of a medication like aspirin. We'll be making aspirin, but within that process, we might get some byproducts that could be poisonous. We would need to be able to separate the aspirin from the byproducts if we were doing this in a commercial setting. So a lot of our techniques are really the separation of mixtures. So the first lab that we'll be doing in this will be an orange distillation. We'll be distilling the scent of an orange out of the peel of an orange. So we're going to be zesting oranges and then distilling that scent. Distillation is an incredibly powerful technique in organic chemistry. It's most commonly and most well known to be used in the production of spirits and alcohol in the beverage industry, but within the lab setting, it is extremely versatile in its ability to separate a large number of compounds just by looking at a difference in boiling points. Our second lab is going to be an aspirin synthesis. We'll be using some starting materials using salicylic acid, a little bit of sulfuric acid, and we'll be using these to create the compound that becomes aspirin. In this technique, we will be making some byproducts that we'll need to purify out of our aspirin. And to do that, we'll be using a technique called recrystallization. In this technique, we often do some kind of laboratory reaction that will create a crude product where it's mixed with a bunch of different chemicals. And we're able to dissolve that product and all of those crude pieces in another solvent and then recrystallize the thing that we're looking for. So we'll learn that technique as well. And finally, our last lab, we'll be looking at extracting caffeine from tea leaves. So we'll be using just regular tea that you could get at any dollar store, and we'll be boiling that to pull all of the caffeine out of the tea leaves, and then we will be separating that caffeine from everything else using some separatory practices. One of those practices, the main one we'll be using in that lab, will be the drying of a certain solvent. Now, when I say drying, what I mean is I might have a liquid solvent that is not water, maybe something like acetone or dichloromethane. We'll be using dichloromethane in this one. That might have some water mixed into it, and I need to pull that water out of it. I can't have any water in my vessel. And so we need to have a number of different techniques for getting that water to leave. And so we'll investigate those in that lab. With all of that said, organic chemistry can be a very beautiful science. It can be a lot of fun to learn about and to investigate, and there is a great multitude of things to learn about. But it can also be very challenging. And this course is designed to be a self-paced course that will be done independently. So there won't be very much direct interaction between you and I. Most of this class will be done through videos and through emails and through side discussions. But if at any point you are struggling, I can always make extra time, and we can always have a conversation about what's going on. So with that said, good luck. Let's get started learning about organic